Swayam Prabha. Digital India. Educated India.
This is the first in the South India, the first college, and it has started in the year 1974 as a survey school. It was, sorry, 1794. It has been instituted by the Britishers itself. The purpose of constituting a survey school is to survey our Indian subcontinent. So they want to train surveyors to do that job. For executing that job, they started teaching us. Otherwise, I don't think if without any intention, they would have taught us. Okay. So we started in the year 1794, and later it has been evolved as a civil engineering school. Prior to 1858, it was civil engineering school. Then later they have named as civil engineering. Okay, sorry, school in 1858. In 1859, they named as civil engineering college. So we got the crown as college in the year 1859. Then 61 onwards, mechanical started, electrical started. They named as College of Engineering, Guindy. Okay, this is the first towards the South India. I could say that this may be the first technical, not college, school outside Europe. So that's the legacy we are holding even now. And with respect to Department of Civil Engineering, we are running 3 UG program. It is a very special that we are running a PG program in a regional language, Tamil medium. And BE Geoinformatics, that is a very special course. Nowhere else here we have BE Geoinformatics, and mainly on focusing on the surveying part. And many PG programs, total count of 10 PG programs we are running, and PhD and MS by research in all disciplines. So without saying this, I cannot start any lecture because I belong to Department of Civil Engineering, College of Engineering, Guindy, Anna University. Now we are, our QS ranking was 385 in the last year. This year we have slipped down 469. Sorry to us. Okay. So now I start the lecture. It is on Precast. I think you'd have been listening about the introduction part in the previous, I think it started 2 days back. Yes or no? So my class generally it will be two-way traffic. It never be one-way traffic. I am not the radio. Kindly respond. Then only the classes will be, what I can say, lively. So you know what is meant by the precast construction. Practicing of casting of components in the factory and bring into the site and assemble it. Earlier we know that this is happening with respect to the steel structures. Kirby is the very eminent factor, but I can say people who manufacture steel sub-assemblage and do the erection at the site. In the same portfolio, people started working in the precast concrete structures also. We are a little bit worried about the, what I can say, mushrooming of various factories or companies working in the area of precast technology, but we have to bring some standardization to that. That's why Professor Pillai is chairing on session, what I can say, to come out with a standard in the precast construction. I have been seeing a lot of companies coming up in the area of precast construction. They are not at all following, what I can say, minimum standards. And I used to do consultancy or extending my service to the government agencies for various construction in the site. So what is happening in the precast industry, the minimum number of people are expertised in that, especially Professor Ramalani is also expertised in that, but he will not, yes, don't want to, what I can say, certify or something like that. So people are coming to us in Anna University, and I am, what I can say, coordinating with my colleagues and doing a lot of investigation on that. Most of the places the precast construction is happening, we used to go and stop the construction, and we will say you have to follow this type of protocol, then only we will be able to certify that. So that is also happening in one side, and but in reality this is a very good practice, precast construction. If we are not promoting, this may come to a halt, because in 1954 Shirke started working on precast construction, but people experienced some little bit of difficulty in the precast construction, mainly because of the failure of the connections and leakage in the joints and all those things, and it has come to a halt. Then they started revamping it, and they are doing a lot of work in Maharashtra for Maharashtra government and Delhi government also. They tried to come and pitch in with Tamil Nadu government, but very little work they could get. So Housing Board and Slum Clearance Board, only two government agency has approved their construction. So we are trying a lot to promote that. So you also should come into that line. Okay, so these are the few pictures. This is from London. London is not too far for precast construction. Even I visited Leeds University and gave a lecture on precast construction. The hall was totally full, because they want to know how it is executing the precast construction. They are not known for precast construction. And this is from Singapore, but they are very much towards the precast construction. The advantage with Singapore and all, they are little bit free from earthquake activities. Seismic activities are very less. They are so comfortable to design these structures for the dead and live load. So that's why they are a little bit happy. This is so this is a residential block at Mumbai. I visited Shirke's factory in 2009 or 10. They took me around, and this is high-rise structure constructed for the mill workers in Navi Mumbai. So this was it was very exciting thing for me when I visited these places. And this is one structure which can exhibit as precast element. It has been constructed by Teamage Precast in Tamil Nadu for Slum Clearance Board. So all these things you would have been listening to for the last 2 days. These are the lot of benefits are there for the precast construction, and thermal efficient, low maintenance, and sound control, Wi-Fi compatible. That is a new thing. People have a projected life precast construction. This is I don't think it is nothing new. And want one more benefit. So precast is completely recyclable. Okay, we can dismantle and reinstall if it is possible. The connection has to be according to, we have to design accordingly, making it environmental friendly choice. So that is the most wanted benefit people are saying. And considering all these benefits, some deficiency will be there with any system, isn't it? So what is the performance of the precast structures under seismic loading? It's a very big question mark. And this is the after effect of northeast earthquake, which has happened in 1994. This is the failure pattern of the parking structures. Here also you can see the structure has collapsed due to the lack of connections. You can see here the lack of connections has been started initiating the collapse of the structure. And you see the next picture. This is from the Turkey earthquake precast factory. You can see one thing, the elements are intact, isn't it? Why? Elements are factory made, but it has been connected at the site. The connections are proper. That's why the failure happened. This is a very peculiar collapse of precast structures, which has been witnessed in Bhuj earthquake during 2001. And you can see all the planks and vertical elements and beam, everything is okay. Nothing is damaged. Am I correct? What is damaged? Only the connections and joint. This shows the importance of doing research or doing much investigation on the connection, various type of connections. So structural elements were intact, joints and connections failed due to inadequate detailing. This particular aspect attracts more researchers to work on the connections. So what are the major issue? Poor connections. And you can see some leakages also in that joints. That was a major concern. During 2018 or SCRC conducted, no? 2016 Structural Engineering Convention has been conducted by SCRC, the director Santosh Kapuria, as well as Professor Mahaprasad. Santosh Kapuria was chairman and Professor Mahaprasad and me were the co-chairpersons for conducting SEC. Part of collecting money for conducting the SEC program, we visited L&T, we met SNS. Then he was telling me, he asked me what is my research topic. And I told I am working on precast construction. I have come out with a lot of connection retailing and all those things I was explaining. Then he was telling me only one thing. If you can come out with a material which has been filled the joints, which is leak proof. If we can bring out some material, that would be the best option for us. So now one of my research scholar is working on, now recently one of my research scholar who is working as a faculty in College of Engineering, Trivandrum, he is working on the topic high performance concrete, micro concrete, replacing the grout of the connection joint. Okay, he is working on it, and I don't know what will be the compatibility of the normal concrete and the joint concrete. If you can prove a better compatibility between this original concrete of the elements and the joint, what I can say, joint concrete, what we are going to pour, then it will come out a best solution that will arrest the leakage. That's what my expectation, and let us see what is that work. Also we are working on durability aspects. Let me see, another 2 more years for me to get retired from College of Engineering Indy. Before that I could do something on that part, well and good. So almost around 7 people completed their research on connections, and this person is working on that. Now joints and connections, we were sometimes erroneously give a nomenclature whether it's a joint or connections. First, kindly understand what is the difference between joint and connections. You can see here, this picture I have taken from Eliot's book. Most of the people would have been giving you the pictures and figures from the Eliot book. And you can see here, you can see multiple joints, tension and shear joints. So you can see here the tension and shear joints in this part. Is it visible? Yeah. So now you can see various, here it is a compression joint where this double is there. Here you can see a compression joint and all these different types of joints. So you can see here a tension joint, and here it is a compression joint, and all this you can multiple compression joint and compressive stress zone and compression joint, and connecting all these different types of joints together is what is called the environs of the connections. What is the difference? The first, different types of joints will be there, tension joint, compression joint, shear joint, multiple different types of joints will be there. The totality of all these joints together is what is called the connection. So in a connection, different types of behaviors will be there. Compression will be there, tension will be there, shear will be there. So now you can see, especially this is a column to beam connection, and you can see the connection region has been named with a dimension is 4 to 5 h of the column. H of the column is this one, okay? And width you can see from the face of the column 1.5 to 2 times of h of the beam. Taking the count from this face of the column, this total region is what is called the connection region. So this is the basic fundamental difference between the joint and the connection. Now I will explain about what are the different types of the joints. And okay, when we do the analysis, it is not a simple thing. When we are telling about the precast and the elements we can design in the what I can say in our drawings, in the calculations, everything, and columns also we are designing. And nowadays UG students are doing only this. They are doing the design of elements. When it comes to the joint, okay, so my humble request, even once upon a time when you will become faculty members, kindly teach them how to connect the elements, and the joint region also you have to teach them. Now when they are going out of the campus and somebody is interviewing them and asking what is the connection and detailing at the joint, they are totally blank. Okay, when I teach RC design, I'll teach fully, but I am asking everyone to teach the complete totality of the design of RC structures. I humbly request you all, faculty members or the students, when you are becoming faculty members, kindly teach the students the totality. Otherwise, it's a waste. waste of time for them as well as we. So when we do the analysis of the joint or connections, we can utilize different types of methodologies: tut and tie method, couple joint method, and shear friction or shear wedging method. I'm not going in depth with this because it is very lengthy process. So these are the various type of methods we can utilize for the analysis. I'll just mention about what are the different types of the joints. The first one is the compression joint. When you look at this part, so this is the joint region is bigger than the column. This is in size with the column, and it is also in size with the column. This is the shorter than the width of the column. These are the different types of the bearings or the connection region what we are giving in between the columns. Okay, so you can see here, this is a structural bearing pad connected. That is actually the total compression joint. Okay, we have to design all these small elements also in detail, otherwise we will be in trouble. And then comes compression joints. You look at here, these are the various type of joints. You can see here, this is a tri-pack, it's a 10 mm thick, and this is supporting element, this is the bearing pad, and this is the supporting, what I can say, beam is getting supported on top of a wall or beam or whatever it, wall or column. And here also you can see, this is the compression pad, wet bedded mortar, it has been used on top of the bearing pad which is been used there. This is a steel or steel rubber bearing pad, 10 to 15 mm thick. All these are the different types of the compression pad, bearing pads, which is supposed to bear the compression stresses in that joint region. Okay, these are the various type of the compression bearing pads and compression joints. Then comes the tension joints. You can see here, tension joints using lapped loops. So you can see here, this particular area, when you look into this lapped loops, this is the plan area when you look from the top, and this is the elevation. All these elements, when it is subjected to compression force, these loops are undergoing the tensile stresses. These are the tensile joints. Okay, and here also you can witness these double bars, when it is getting, this beam is getting loaded and this particular area is getting stressed with the joint shear and all, these double bars will undergo a tensile pressure. Okay, so we are supposed to design even each and every minute aspects of the joint region also. So there come, now comes the shear joints. Shear joints, I have taken some more that. Okay, fine. The shear joints, whenever you look at the doubles, it will be undergoing the shear action also. Double shear, you would have been studied in soil mechanics, double shear test, isn't it? Similarly, all these doubles, when it is connecting through one particular element and passing through the other one, it will be undergoing the shear stresses also. So this comes under shear joints. And you can see here, whenever you are feeling like there will be a transitional motion between two structural elements, these are the two slabs that has to be connected through the joint where we have to provide shear keys. Okay, so shear friction we have to consider. Whatever be the double bars, we should design these double bars to take this double shear also, and we have to provide shear keys and mechanical devices to arrest these type of the shear stresses wherever the connections demanding for the shear stress resistance. Okay, this comes under the category what is called the shear joints. Now comes the major part. We are generally going with, generally most of the RC precast elements are designed with the moment resistant joint. Now you just look at this beam column joint, that also is a moment resistance. We are not releasing. Some elements, some structures we can design as a pin jointed connection. I'll show you the next, after end of my presentation, I'll show you what is the difference between the pin and moment resistance connection. This is the moment resistant connection. We are allowing the joint to take moments, not only here the beam column joint, as well as for the foundation, what I can say, column foundation joint also, we can design as a moment resistant frame. We have to design these elements and the joints accordingly. That's the important thing. Now I'm going to discuss about, till now I was telling about the joints, now comes to the connections. So the connections, basically 4 rules we have to satisfy with respect to joint and connection. Satisfactory joint design, which is further taking to the connection region, and the component can resist ultimate design loads in a ductile manner. We have to make sure that all the structural elements connecting in that joint, as well as in totality as the connections, each and every element has to be designed to be as a ductile element. The precast members can be manufactured economically and be erected safely and speedily. These are the what I call protocol tenements, wheels, tenements. That similar way we have to follow the 4 rules. The manufacturing and site erection tolerance do not adversely affect intended structural behavior or are catered for the worst case situation. And the final appearance of the joints must satisfy visual, fire, and environmental requirements. These are very, very important. The last one is extremely important, but why? Because whenever we are thinking about the safe joint, architecturally we cannot make it pleasing. There also, it's about the there should be a balance between the structural safety, strength, and visual appearance. All these things should be matched together whenever we are designing any structural system. This is the various different types of the beam column connections. So finally, I'll start from one A, B, C, D, and you have to tell me which is the best connection. Okay, in the connection A, what is the speciality? Column is continuing, beam is broken. Okay, and it is getting connected. What is with the B? On either side of the column, there also the column is continuous, beam is discontinuous, and one side it is getting the 2 options are there. There can be a haunch or a corbel. Okay, and what about C? Both are discontinuous. And D, beam is continuous at the joint region and column is discontinuous. The joint connection is getting the beam, the next beam is getting connected to the beam away from the joint region or face of the column. Okay, out of this, which is the best? D is good. I'm not saying no, but there are difficulty with respect to the construction process. Construction procedure is a difficult task, and from the start, A, what is the difficulty in A? There are mechanical connections, billet connections are there. It is erected. And B, corbel is there, haunch is there. That is also good. What is the difficulty in these 2 things? Corbel shuttering instead, we cannot make it because that is not a big deal. And architectural appearance also, the architects will appreciate. They will be ready. The only problem is manufacturing column for a long height. How many stories we can construct at a stretch? We can manufacture at the plant by putting a long stretch of factory, and we can manufacture. How it will getting transported? So that is the practical difficulty with respect to following either A or B. 1 or 2 floors we can manufacture at a stretch. And ultimately, I'll tell you what is the problem with C. Nobody is appreciating C. Why? Okay. So otherwise also any junctions, traffic junction, that is also dangerous, isn't it? Here also C is a dangerous thing. But most of the construction in the practice following the C. That is the unfortunate thing. We are following the condition C. Both are discontinuous. That only gives the flexibility in the site. There, what? Yeah, it is not dry connection. Generally, it is an emulative connection. It's a hybrid connection. There will be mechanical elements as well as the dry plus wet. That I can say it is an emulative connection. They will follow. Generally, people are following the connection C. So because of that, we have to give more importance while designing the connections. Okay, continuous reinforcement will be provided as a double bus. Another one column to another column as well as one beam to the other beam. Proper connection has to be there. That is the challenge. how we will provide the proper connectivity between the beams as well as the columns. It's a total, what I can say, it's a junction. When you think about a traffic junction, how much the challenge the traffic police is facing, the same challenge we have to take and do the design appropriately. Without harming both the features of, what I can say, the best feature of the joint with respect to the elements are, they are factory made, they are perfect elements, and how good we can make the joints matters a lot. Now you see here in this case, columns are continuous at that particular joint. It is not always, okay. So we can even cast these beams continuously at the site and the factory and bring it 1 or 2 bays. And if that is the case, the columns as well as the beam can be connected through like this. And what is the specialty here? You can see here, this is the bottom column and the road is protruded out of the bottom column like this, okay. And this beam has to be erected to this dowel through a hole provided in the beam, as well as the upper column has to be erected exactly on the protruded dowel bar. There will be a casing inside every, what I can, but how many bars are protruded, that many cavings also there in the upper columns. Accordingly, we have to provide, and this tri pack, that will be as a compression joint, okay. This particular region will be a compression joint. Top we have to provide a tri pack, and after placing these elements, beam as well as the column, we have to do the grouting through the available space and fill it up, okay. This grout, yes. Yes, this beyond this, that will be a development length under compression. Above the beam, how much is it? Yes, 50D, 60D we will do, no? The same thing we have to be provided above that beam level, what has been protruded. Yeah, deconnection can be. Yes, yes, it is. We can simulate to that. And same is here also. Here, what is the beauty is, the bottom bar coming here, we will provide a pocket, corner pocket with anchor bars welded to the plate. There we will put a bolt and connect and fill it off. Okay. So that connection is not continuous. The answer to the previous question, how much development length, it is not giving any development length. It is anchoring and tightening it there itself. And this pocket will be filled with grout later part. It will not be visible outside also. After finishing, yes. This is a moment joint, moment resistant joint, all these things, okay. Base plates, very similar. There will be a plate here. To that plate, it will be the dowel coming from the bottom will be coming out through the plate, and we will be bolted, nut and bolt, we will fix it, and it will be grouted. And when after finishing the work, it will be look like a in situ, what I can say, in situ construction. Here there will be a plate, no? Here at the base of this column, there will be a plate, it will be welded with that particular plate. The top bar, end of this top bar, there will be a plate. That it will be connected to that particular plate. It's actually like a not a budging plate. One plate here, the other plate here. This to this plate, it will be getting connected, and there is a pocket. There will be pocket available. Above that pocket, there will be base plate. To this base plate, the top bar will be welded. Understood? I don't have the picture. So it is simple. This is the top bar, no? Base of the plate, there will base of the bar, there will be a plate. That along with the plate, the concreting will have been done. Okay, it is an factory made thing, no? There was a plate outside, and the concrete, the bar will be protruding, and the concrete would have been above this particular plate. So when we look into this particular joint, there will be a plate at the top, bottom plate, here the protruded nut and bolt, and this portion will be filled with the grout lead. I'm talking all the connections related to the construction of the buildings, only buildings. I'm not going beyond that. Infrastructure like bridges and all, I didn't consider. Only buildings. Buildings, all connections are with respect to the buildings. Yes, each and every bar has to be connected like this. There you can provide a total, but it may be considering the distance between the two bars can be connected to a single plate. Okay. Yes, of course. Yeah, all bars has to be entered to the sleeve, and the sleeve has to be filled with the grout later part. I'll show one video. Yes, yeah. Ball has been extended, ball has been lower. It has been routed. Main bar it has been connected. How the interconnection of the bar? How the interconnection of the bar? Yes. Yeah. No, that will be there, no? Here in the joint region you are telling. Yeah, that is a difficult task, but that can be thought about while we are casting the beam itself. Understood? In the beam, yeah, your question is very much correct. That will be taken care by the beam region, whatever be the ductile detailing region is there, no? On the columns as well as the beam. That part we can. And this part we have to taken care appropriately when we are thinking about. So the double bars can be provided. This is the double bars. In otherwise, we can provide internal 4 bars. The double can be provided inside the beam itself. If we need it, we have to think about plate. Plate is above the beam only, no? Yeah, you are telling is correct. So it's almost like what I can say, it's a discontinuous sort of thing. The top portion, and it has to be what I can say, the proper connection between the upper portion and the bottom portion is through this double bar and nut and bolt. No, nut and bolt collection above that, what I can say, the beam level, up above the face of the upper face of the beam, not within the region. See, now when we think about the residential building or multi-story building, the number of bars within one column region is not too much congested like what we are seeing, what I can say, the pier for the bridge or nothing like that. Yeah, if it is high rise, the column sizes also will be little bit higher, isn't it? It is not too much congested as if what we are seeing in the infrastructure buildings. For when you think about to what I can say G plus 4-story building, we need a column of around 300 by 600, and the number of bars may be 8 or 9, 8 maximum 10. So the spacing of between the bars may be sufficient enough 200 mm, 300 mm. So that can be accommodated within this plate as well as the what I can say, the spacing available. Okay, with respect to the buildings, this is possible. Not maybe may not be possible with respect to the infrastructure buildings, structures. Okay, thank you for asking questions. Okay, this comes with the corbel, beam column connections with the corbel. You can see here, this is the, you can see this is the column, and with respect to this particular portion, beams are coming and resting to the column from either side. The corbels are on the either side. Here the beam is coming and resting here, and this particular portion is open to sky. That's why it is only one side corbel and here one side corbel, and here the top region, and this is the actual picture from the site with the corbels connections, and this is the beam column connection, dry connections. There are I think he is going to talk about the dry connections. Here also you can see the bottom, there is a, it's a, what I can say, nib or corbel, you can say. The corbel is protruded, and on top of the corbel the precast beam is sitting, and this is the column. It has been connected through an angle, okay, stiffening angle. The bar, the dissipator is starting from here and going to the bottommost portion. The bottom portion is supported by corbel plate. There is a plate, then corbel, and the beam, and the plate angle section on the top, and the rod is connecting all the three together. And similar way, it has been, this plate is getting connected to the column through another plate over here, the column washer plate, precast column and cleat angle, and this is the typical dry connection. Okay, and it will not be visible outside. The beam is here, no, on top of this slab will come. Okay, it will be totally covered. After finishing the structure, you would have been seeing only this nib portion outside, nothing other than that. So this is the picture of dissipator, beam dissipator and double bar. This double bar is very much essential, and later part what will do, know, there will be a sleeve here, it will be grouted and fixed. Okay, there you go. Yeah. No, we have to design the what I can say, joint region of that beam column connection. It will be a combination of shear as well as the what I can say, tension in that region. Mostly it has to be designed for shear. We are doing now. We don't have the code provision now. And Dr. Amala and Dr. Pillai and me, we are developing a code. And especially on connections, I've written, but I am not so happy with the content. We are revising and doing that. Okay, it does no connections now. Okay, definitely. Textbook. That way we have to, yes, we have to bring out a detailed caudal provisions, or I can say a handbook sort of thing. So I have developed a chapter more than around 80 pages, and Pillai put on a strict rule, it should come down to initially 40, now it is 20, now it is 15. Whatever I dreamt of, it couldn't be. So the connection can be a separate book, then only it will, you can learn. Yes, with detailings. Yes. What I used to tell my research scholars, you compile all the work what we have done and you publish. That's what I'm telling everyone. So we are doing that now. Yes. We have to design the corbel. We have to design the corbel for the shear as well as the moment, overturning moment. No. So we have to provide additional reinforcement detailing at that joint. The sizes will not predominantly increase, because otherwise also the column supposed to take the moment coming from the beam, isn't it? Moment as well as the shear coming from the beam. We are designing the column for that. The shear will be there as well as the outturning moment from the beam is there. So what is additionally happening? It is the little bit of P into E. So additional outturning moment, that will not cost much. Yes. So take care of the tension coming in the region. Okay. So this is this is nothing but we are providing what I can say, extended what I can say, forgot the development length, isn't it? Why we are giving development length? Already reinforcement is sufficient enough there. This double bar is playing the role of a development length in tension. That much length we are providing. So if something happens, and definitely that joint region will be experiencing tensile stresses. In order to take care of anything comes, we are providing the double bars in that joint. It will be grouted, and after that only plate will be provided. Because we are not, what I can say, the majority of the connections are dry connections. Only one particular double need a but grouting, isn't it? That double also is initially it will be protruded, and I will tell you, it will be already inserted within this column and what I can say nib region, and it will be protruded beyond this nib, and only this portion will be seen outside. Okay, and all the other connections, the 99% of the connection is dry connections. Okay, anything else? Okay, this is a typical hybrid connection, emulity connection. We are almost all construction, what a precast construction industry is following. Now you can see here, this is the bottom column with two corbels on either side, and that provides a spacing for the beam to sit. You can see here, this is the compression joint, I'll say, both the sides, and these are the protruded stirrup outside, the stirrup portion coming outside, and it will place, this beam will be placed in position, this beam will be placed in positions, and from this bottom column, these double bars is protruded outward. Okay, so what is finally doing, we will make the beam to sit on this corbel, this beam on this corbel, and what I can say, this particular portion which is protruded outward, this hatched portions are in situ, and this longitudinal bar will be inserted through the protruded stirrups. You can see here, these are the protruded stirrups. Okay, the longitudinal bar will be inserted through the stirrups and will be with the binding wires. Then this portion will be, what I can say, filled with in situ concrete with the sufficient formwork on either side. Okay, and this protruded bar coming out of this column will be protruded outward here also, and the top column will be inserted, and this sleeve will be grouted. Okay, generally we will provide the pressure grouting. This is the type of connections followed by Shirke. Shirke has patented this connection, and there was very strong discussion between the Shirke technical people and me. The problem is that it is a patented connection, cannot be included. They cannot give it to include in the code. Am I correct? So nobody will be ready to give a patented connection what they developed to become a public document. So they are not ready to give this connection detailing to us. We are unable to provide this in the 20 years. I am not. Just when Kajale comes, kindly have a discussion with him, because we had a very hot discussion between us, both of us, and that too in presence of their vice president there at Pune. bars. So actually this will be protruded outward from this point and this point towards like this. And at the site, when they are about to erect, they will bend it upward and it will be connected through another roads here. You can see here. Okay. And to the doubt to somebody's question, how the double bars interior, the additional double bars, they are, but I can say stirrups they are providing at this connection region. And here the double bar is coming up, isn't it? This stirrups is connecting this double bar and this double bar. And interior portion, this additional bars you could see inside here to here. These are the additional bars. These are the connection between the bottom column and the upper column. Okay, and the what protruded stirrups will be here. This is the longitudinal bar inserted through the length of the beam. This is the connection between the beams. Actually, this is exactly the connection which I have shown you. See, all elements are disconnected. It is getting connected in a single joint. Okay, both the beams are getting connected through these bars and the columns are connected through the double bar. You could see inside this. And see, whatever Professor Amalan has told, this particular outer shell is the formwork for them. And the whole, the interior portion is cast in situ. It demands lot of work at the site. Not it's I always used to tell Kajal that your connection you cannot claim that is a precast connection. The construction is also not precast construction; it's a hybrid construction. He may give a detailed explanation on that. This is exactly a longitudinal view of the beam column connection. You can see here the end of the connection, the top bar is coming and connected like this. You could see here, these are the connection joint. And here the extension of the beam. This is the additional bars and the longitudinal bars coming here. This is the sectional view of that. The bottom bars is bended upward and it is bended. So this is the longitudinal view of a beam column connection. So two connections here, isn't it? This is the end connection. This is the intermediate connection. So this is the actual view. This picture has been taken from this metro rail station, Kalamassery, Kerala. This has been practicing by the team age people. So you can see here, this is the nib protruded outward. From here, these double bars are protruding upward. And you can see a ridge over here. You could see here in this picture. And it will come and sit over here. Okay, then it will be the interior portion will be filled with the in situ concrete. The final picture will be like this. Okay, and the upward portion, whatever is here, it will be bent to and fro. It will form like a formwork. Then they will insert the longitudinal bar and fill it this portion also. That's what is happening. Okay. So this is the beam column connection, billet connection. Do you? I don't think I have. Video is not working. Huh? Video will not work. Okay, I'll show the video separately. So I'll show the separately. So this is the beam column connection splice sleeve. You can see here. This is the beam and two columns, and the beam is getting inserted here. This joint will be filled up with the in situ concrete. And this is the column to column connections. You can see here. Initially we had a discussion, isn't it? How we will be getting connected. So you can see here, this is the bottom bar coming up here. There's a plate, fully it is getting welded with this one. And the top bars will be getting, so you can see the protruded double bars here, isn't it? It will be getting connected on the plate. Okay. And it will be, this is the shims in between, that is the compression joint. So this will adjust the leveling purpose it will be used. And finally what will happen, this protruded bar will be what I can say, fixed with a bottom belt. And finally it will be filled with the entire joint is a dry packed with the grout after. Okay, here you can see this is the actual picture from the site. Okay, bottom of this column, it will be like this. The pocket will be provided like this. It has been arranged. So this is the column to column connection. See, this is the sleeve. So now the bars will be protruded and it will go inside these sleeves and it will be grouted later. And this is also a video. I don't know, video is working. Okay, not working. Yes, working. Sound is not there. Huh? No, it's okay, fine. So this is the construction at site by the teamage group. This anyone free, if you have free time, you can go and see Bellacheri Chennai Silks building. From that site only I have taken this picture and it is erected. You can see here the protruded. No, no, building only is available now. The construction is long back. Chennai Silks, Velachery. So this is the erection of the beam on top of that. Yes, everyone will ask this question. Wherever I projected this, they used to ask. This is the beam to column through connection, beam to column. That later it is not a pressure grouter also. Back. Yes. Stop. Thank you. So slab wall connection, you can see here in this, this is the slab and this is the wall. You can see here, it's a thumb down sort of thing you could see. What is the purpose of that? Can you tell? Yes, correct. You are a practicing engineer? Where are you working? Very good. You would have seen this picture. Okay. So in order to arrest the protrusion of water, rainwater towards the joint region, they provided like that. And it's actually, when you look from this side elevation, it is a projection outward, isn't it? The architect would have done a, what I can say, appropriate maintenance on that part. But later part, there was a discussion on that. They have changed like this. You could see here. So not the thumb down, a small finger down. Okay. So that way that has been changed. You could see here. Anyway, ultimately it will be, they can flesh it out later part when they are doing the exterior part. So this is the slab to wall connections. These are these two walls and the slab is in between. So you can see slab to wall connections. If it is an interior wall also, you can see this is a top wall and this is the top wall. Somebody was asking about the joint forces, isn't it? We have to design for all these forces. The analysis we have to do and do the design for that. And this we have to design for this overturning moment as well as whatever be the shear coming from the columns and axial load from the walls also. This is the wall, slab to wall connection. I'll go little faster. I think I was teaching till now as a very slow pace. So this is the slab to beam connection. You can these are the slabs and hollow core slabs. Mostly people will be going with the, if it is precast, going with the hollow core slabs. And you can see here there will be a double bars connecting between the holes and the interior portion will be grouted later part. So this is the beam and this is the protruded stirrups region. You can see my mouse. Okay. So this is the protruded stirrups and this is the longitudinal bar. Same thing is extending here as well as a double cross bars between these slabs will be here and everything will be connected at this joint region and it will be filled with the grouts. This is the slab beam connection again. You can see this is what I can say, the precast beam running. On top of the beam, additionally slab is coming and getting connected. You can see the exactly the similar way. This is the interior connection, this is the corner connection or exterior connections. So I'm not running this. Can I run? If something gets stuck, I don't know. It's not working. It's not working. Anyway, I'll show you later. These are the precast walls, and this is the precast wall to slab connection. You can see here, these are the stitching required. These are the wall with the holes in intermediately. You can see how it is. These are the sleeves. Into the sleeve, the double bars will be getting inserted, and for that this holes, and this also the interlinking tongue and the groove connections here. You can see these are the extreme edge. Whatever later part, it will be grouted with the in situ concrete. Here the protruded interlocking links will be there to getting connected along with the next nearby slabs. Okay, these are the protruded bars from there. Here also, and this is how it is getting connected to the precast wall to the slab. The casting of the thin walls at the side. Just I have shown a picture for that. And these are the wall to wall connection. There are multiple loops people are using. I think in an IIT, your student or my professor students. Yeah, so he has done a very good work on this loop connection between the walls, and here there is one loop coming from here to here, as well as another loop coming from here to here. Interior portion, there is a longitudinal bar has been inserted, and it will be grouted later part. It has shown a very good result. Who approved? Not that much good. So none of my students did on this connection, wall to wall vertical connection. Horizontal connection, one of the guy has done now this part. So I'll just see what is happening in IIT and what else I can do there. Like, so wire loop box connections. I think one of the student of yours has done the wire loop lock connection also, the vertical connections. No, one student. So these are the different type of connection. You can see here there is a wire loop, and it will be getting attached with the interior of the inner columns, and this will be protruded outward. That will be getting connected through the longitudinal bars. And how it will look like this, and the interior portion will be filled with interior grout by providing formwork on either side. This is the wall to wall connection, vertical connections. And these are the different types of the connection. You could see here, it's a spider web connection sort of things are there for the connecting between the walls. This picture I have taken from the what I can say, Chennai Silks building team has constructed, and these are the vertical joints, multiple vertical joints between the wall to wall connection. You can see here, during the erection process, it has to be supported like this, then only the stability will be getting for any type of vertical connections or whatever be the connection. These are the horizontal connections. One of my student has done this wall to wall connection. This is the cast in situ grouting we will generally done, and half grouted sleeve on this part, and he has used the couplers for the connecting. I told you initially what is the difference. I'll show you what is the difference between the pinned connection as well as the rigid connection. You can see here in this pinned connection. So this is the link dowel coming out of this, and only a compression joint here, and it is not moment resistant connection. Okay, it is just resting on top of that. Same thing is over here. This is a bigger column. On either side, beams are coming and resting on that. It is just a pinned connection, and it is not connected. These beams are also not connected together. Okay, what is the advantage of here? We need not design this joint, the connection point for the moment. It allow rotation. It's only pinned connection. It allow rotation, and allow rotation this way and this way, as well as here also. It's a very simple connection. When you do the analysis also, the beam has to be designed for a simply supported moment only. We need reinforcement at the bottom of the interior portion. So like that we can design. If it is a pinned connection, we need to be much careful when we are choosing this pin connection. That cannot be chosen for multi-story buildings. Maybe one story, what I can say, warehouses or industrial sheds or some sort of things, we can go with the pinned connection. Otherwise, we have to go with the rigid connection. This is exactly a typical rigid connection. Okay, beam it's running here as well as slab is also. This is a beam to column connection. All these connections are rigid connections. Okay, Mostly we have to look into that. What are the features we have incorporated to arrest the rotation? There it comes the moment resistance. Right? Yes, please. Which one? Yeah. If you want a pinned connection, only one bar is getting connected, not multiple. Okay, that will allow rotation. Okay, and sometimes the towel bars undergo a ductile deformation also if overloaded. Yeah, give some rigidity. We have to be what I can say, judiciously choose what should be the double dimension also. It is possible for only one story buildings, more not more than that. So I'll not take much time. I'll browse through. In research, what is happening in Anna University, one of my first student, Dr. Vijay Priya, just after what I can say, Bhuj earthquake, multiple figures, photos I have seen for the connection failures. Then I suggested my scholar to do research on precast connections. She has done a mechanical connections. She has published a paper in AACE performance, constructed performance of some journal she has published. And when she started her research, this is for the students who are doing research. When I gave this topic, she told, ma'am, I am not getting any literatures. No published papers is available. It is quite difficult to pursue with the continue with the research. You tell me what may change the topic. Then I told, if you are not getting any papers, published papers, well and good. Once you publish, your papers will get lot of citations. Now I think her paper is got around 6,000 citations. So that is the thing, the beauty. She has done a very good job, and now she is working on this, especially on this topic. And that day when we are discussing, I was telling Pillai that he told we have to start courses on precast. That in 2004 we started. When I gave this topic to Dr. Vijay Priya, then I told the best way to learn is to teach. So kindly offer an elective course on precast. So she is teaching the precast construction even now. That is the elective that we have earmarked for her. She is teaching from years together. Okay, these are the various connections she has emulated. All these dry connection. This is the loading protocol we followed, and you can see here these jacks, and these are the loading protocol we followed, and this is the failure pattern. And I'm not taking much time. She has modeled in ANSYS and verified, cross-verified along with the what I can say, experimental results. These are the observation. This type of connection with the cleat angle with stiffener, two stiffeners with the energy dissipator on both the sides. This particular joint has given the most efficient result, both what I can say, strength, durability, energy dissipation, all aspect has been covered with this particular joint. And Dr. Hemamati, she has done on work on beam to column to foundation connection, multiple connections she tried. With the pocket connection, she has provided different types of the detailing for the pocket. And we got papers published in advanced different journals, AAC journal also, and she got a patent also on her beam column to foundation connection, especially for the pocket connection. And this is the wall slab connection. Dr. Arati, she completed long back, and she published around 4 international journal papers. I suggested all my research scholars to compile all the papers together and publish one book. So I led it like that. And for her also one patent is there. Almost all the students who complete the research, I'll suggest them to do the patent. Her work, wall to slab connection, she has tried a different type of connection. You can see here, this is one double, and this is the U connection, U double, and two U's, one from here to here as well as here to here. And similarly, she has done this also. This is the thing you asked, somebody asked, what is the role of this double? Are you remembering? And along with the dry pack. So all these specimens behaved well, and especially this type 3 connections has extremely done well with the joints. And for promoting the precast industry, And 5 research scholars completed, especially from Anna University. I'm telling 5 of them has completed. One is pursuing now for the grout development. And I authored 2 chapters. One is along with my professor Mayor Prasad on soul, and self and scholars contribute 1 chapter to the connection of IS code, and seminars on precast construction during 14 to 18. Later part we missed. Am I correct, Pillai? We started yearly once, and I delivered lectures on in UK, Leeds University, ICI multiple lectures, and CBRI Roorkee, E-Structures Pune, and many colleges in Tamil Nadu, Kerala. And this is our product. Amalan sir also will support me. It is very much available with ICI headquarters. It covers these contents. Yeah, okay. I'll tell Radhakrishnan. Yeah, okay. So this is our contribution. Amalan Pillai, everyone has contributed towards the development of this. As Dr. Amalan told, it has been initiated by Dr. Ramakrishna. It was a painful thing for us, but we could made it happen with his blessings as well as Pradeep. So finally we have done it in 2015, I think, 15, 14 or 18. Yeah, I took charge as chairman ICI Chennai chapter from 14. I think 17 we published. 17 we published. So I got an opportunity to continue for second term also. I think first term itself by 16 we published this. Thank you so much.